No doubt, some of the power of the pre-Agile project management techniques look tempting. That temptation is how features for waterfall techniques are creeping into Agile project management tools, along with some other Agile-specific features that are supposed to be helpful, but in fact increase complexity while not delivering value. Before applying tools of the dark arts of pre-Agile project management to gain insights into software projects, project managers should have a thorough knowledge of why those approaches failed. Applying traditional project planning and tracking to software creation is inflexible, even when it is applied by skilled practitioners. Something has to give. One thing that trips up pre-Agile tools and techniques is the difficulty in determining the completeness of software tasks. That is where this line of the Manifesto for Agile Software Development has something to say about task completion. Working software over comprehensive documentation. There's further clarification in this Agile principle. Working software is the primary measure of progress. A construction site manager can look at the steel frame of a skyscraper under construction and count the floors that are completely framed. But how can a software development project manager tell the completeness of software? What if, when it first does run, it doesn't work correctly due to a serious error in the code? Now you have another task to wonder about. How long will it take to correct the error? The rigid structure of a project planned the old way leads to misreporting the status of tasks. When that happens, a project is on the road to hell. Waterfall methodology software projects frequently die with some percentage of many tasks reportedly complete, but with few of them actually finished, done, tested, corrected, put to bed, not needing to be touched ever again. Software that is reportedly partially complete is often completely without value. You can't take a failed software project where the reported sum of semi-complete tasks adds up to 80% of the work to another development team and expect them to take 20% of the projected time to complete the job, not even 40% or 80%. That approach can very easily take more time than starting from scratch. Unless a software task is complete and can be tested, actual completeness is not knowable. The elaborate interlocking schedules and task estimates in PERT, Gantt, and critical path method charts are inaccurate for software projects because estimates are made far too early, because partial completion lacks meaning, and because planning is difficult and time-consuming to revisit. Systems analysis-style project plans have informative value in aggregate, but their details are a source of seductively scientific-looking visuals, unrealistically tight allocation of resources, and missed opportunities for innovation. They subsequently cause demoralizing evaluations of teams and team members. Executing a traditionally planned project often depends on rigid adherence to the schedule, no matter what was learned on the way to completing a task or a group of tasks. This, in turn, has the effect of encouraging timidity, at the very least, or destroying team morale and causing team members to seek other employment. Contrast the intentional embrace of novelty and risk in many software development projects with the kind of projects, for example, building a series of overpasses over a highway, where conventional systems analysis-based project management tools have proven their usefulness over and over. These projects are characterized by repeatability. The soil under the bridge supports is analyzed the same way. The steel meets established standards and specifications. The concrete has the same characteristics and ingredients as many other previous projects. Learning happens, but it isn't learning on the fly. Most of the learning is already in civil engineering handbooks, some published decades ago and without need of revision. In civil engineering and similar fields, learning is mediated by standards and practices that are designed to change slowly. Risk is driven to a minimum. The chances of departing from the schedule are relatively low. with known causes, such as interruptions in construction due to weather or an equipment breakdown. Therefore, even the variations in a schedule are subject to prediction. Seldom is there need to puzzle over why some task did not meet the plan. The apparent precision, efficiency, and certainty available with traditional project management tools is very attractive, but it is also not applicable to projects, like many software projects, that lack the regularity of construction or civil engineering projects. Are traditional project management tools bad? After all, they've built ships and skyscrapers and roads. They were created by smart people in high-stakes situations that required innovative management techniques. Some of these tools are true breakthroughs in rational, efficient management of large and complex projects. Using these tools cleverly can even make managers of Agile projects and teams better at attaining agility. But for the reasons already presented and others, they often fail when used to run software development projects. Traditional project management tools are not themselves bad. They are bad when badly applied to software creation. Many of the pathologies of applying traditional project planning tools to software development can be traced to the failure to recognize the ways in which software creation is different. Software creation is about doing new things. Unlike manufacturing widgets, building buildings, or paving roads, once one kind of software has been created, millions of users can use it instantly all over the planet. Worthwhile, newly created software, especially the kind that matters to most business outcomes, is truly new and unlike any other software in these kinds of projects. Many significant software implementation tasks have never been done before. If new bridges were made of tens of thousands or tens of millions of unique handcrafted parts, with the quality of each part highly dependent on the skill, intellect, and craft of the maker, traditional project management tools would be completely inadequate to the task of building bridges. Risk is an indicator of a worthwhile project. Innovation involves risk. Without risk, a software development project is probably not creating enough value to be worth the journey. In contrast, bridges and dams do not provide more value through intentionally increasing levels of risk. It is easy to mismeasure software task completion. Risk, failed attempts, and tight schedules are in constant tension. The best and brightest coders on a project will take on the largest risks. When taking on these risks, it's counterproductive to try and stuff these tasks into the tightest possible schedule estimate. In fact, there's a strong argument against doing any estimating for many kinds of tasks in a software project. Consider that the only accurate measure of a risky task in a software project is only apparent retrospectively. Process is seductive, but often unattainable. Process sounds like a good thing. It is redolent of reliability and repeatability. Process promises certainty. What manager is not comforted by certainty? Traditional project management, when applied to software creation, creates the illusion of seductive things one can never have in real life. In real life, many software projects and products started with little or no management input and little or no process at all. To managers, it seems obvious that adding process will be beneficial. In managing software creation, for reasons often related to the difficulty of measurement in software development, the ability to apply or improve process is often futile, and the best course of action is to learn to live with less process and less certainty. One way Agile can be summed up is a simplified project management that leaves out the things in pre-Agile project management that do not work well when applied to software development projects. It is better than the systems analysis style of project management, partly for not trying to be as precise and predictive because accurate predictions pertaining to software development are often unobtainable. Focusing on people rather than process breaks the inflexibility of process and fosters adaptability. Focusing on working software directly addresses the problem of partial completion and misreporting in traditional project management methods when applied to software. These and other distinctive characteristics of Agile as an approach to software project management make Agile uniquely suited to software creation. Agile recognizes that comprehensive estimates and fixed-bid projects are often doomed for software projects with significant risk, and enshrines responsiveness and iteration instead of rigid plans. Collaboration, avoiding blame, embracing risk, accommodating change, all of these are positive qualities of Agile. Agile not only places an emphasis on people, it creates a dependency on people knowing to do the right things at critical points in a project. Agile has shown better results than traditional project management, so it isn't surprising that Agile is widely used and widely considered a large improvement in project management when applied to software projects. Agile isn't just putting people before process. Agile puts coders and their code at the center of a software project. Coders are the most numerous and the most expensive part of a project team, so centering them makes a lot of sense. The way coders think about different parts of a project is critical to success. They won't all think or work alike. In contrast, traditional project management tools make it easy to treat people in a project team like interchangeable laborers digging ditches. Agile, meanwhile, focuses on 100% completion and on achieving a level of quality in completing a task that means the task won't have to be revisited unless the requirements, design, or other goals that created the need for the task change. For coders, this is the great achievement of the Agile approach, and perhaps the most important difference in an Agile project versus a traditionally managed project. Agile makes room for coders to focus on code and harnesses that focus for the sake of achieving quality, innovation, and true task completion. When Agile is practiced according to its stated principles, the entire organization relies on the project team for success. The best architectures, requirements, and designs emerge from self-organizing teams. For project managers, the emphasis on iteration and collaborative assignment of people to tasks, rather than on schedule optimization, is central to Agile's advantages over sophisticated but inflexible methods. It isn't an accident that Agile is highly dependent on the quality of the people in a project. Agile was designed by coders to enable them to do their best work, to craft excellent software. Continuous attention to technical excellence and good design enhances agility. Project management as applied to software needed to be different. Those differences are the result of a journey toward better approaches. Those differences add up and result in project management activities being different. In waterfall planning, detailed specifications are created prior to commencing implementation. In Agile, you have a less formal planning stage. A concise description of project goals is sufficient to launch a project. In waterfall planning, complete task descriptions are needed. Tasks have to be described in enough detail to estimate task durations prior to commencing implementation. In Agile, projects can commence without a complete task list. Tasks only need detailed plans as they are prioritized and when implementers collaboratively make decisions about task assignments. In waterfall planning, detailed task assignments are created up front. Resources, which in the case of software development usually means implementers, are assigned to tasks before a project commences. As with task dependencies, critical path analysis requires this level of detail in planning. Otherwise, resources can be overcommitted, making critical path calculations invalid. In Agile, task assignment is tactical and iterative. Short iterations are preferred in part because short iterations minimize implementers waiting on other tasks to be completed. In a waterfall plan, critical path analysis provides precise project forecasts. Critical path analysis, combined with resource leveling, calculates project duration, taking into account both task dependencies and resource constraints. In Agile, project duration estimates cannot be precise. Only a rough estimate of project duration is possible due to a lack of complete task descriptions and task assignments. Agile acknowledges and incorporates some of the fundamental differences between making software and making most other things. Instead of trying to hammer the square peg of software development into the round hole of critical path analysis, as seductive as the results of that analysis might be, Agile explicitly forgoes that level of precise prediction. Short iterations in Agile software development projects are not just a nice way for colleagues to collaborate on software creation. They substitute for the intent of detailed critical path analysis, which is to avoid excess slack time. But instead of having to replan a project as discoveries about requirements and implementation tactics emerge, Agile is designed to take those changes in stride. Agile lets go of the things that are difficult to achieve in software development project planning and management. The ways that Agile projects can go wrong can often be traced to attempts to regain lost certainty. Just as pre-Agile approaches to software development project management failed because they are brittle, so too do these attempts to recapture certainty induce the same brittleness. Just as powerful tools based on systems analysis concepts are seductive, so too are powerful and complex tools that claim to support the Agile approach, but are just retreading the old ways of project management. Keeping the practice of Agile simple is not just virtuous, it is the way to avoid getting tangled up in the same complexity trap as pre-Agile approaches. This does not mean that the systems analysis style of project planning and management is useless when it comes to software development. It just has to be approached with knowledge of its limitations and with appropriate caution. We will explore, in detail, the safe practice of the dark arts of project planning and management, and how to make the use of them without corrupting agility as projects proceed. Even well-executed Agile projects can encounter challenges. Despite those challenges, you should be able to confidently adapt Agile to your unique circumstances and handle adversity effectively. A common but unhelpful response from some Agile practitioners is a no true Scotsman fallacy, asserting that no true Agile practitioner would rely on contracted developers or off-site workers, or handle daily status as a message thread, or other deviations from Agile orthodoxy. This mindset falls short in the real world. Most enterprises lack all the in-house expertise required for their projects, and Agile experience is often scarce. Many businesses embarking on software projects may not even have any dedicated software developers at all. Expecting teams to intuitively grasp Agile principles, or for senior management to communicate seamlessly with project teams without guidance, is unrealistic. Enterprises must work with the resources they have: internal staff, external consultants, contracted coders, and deliver software quickly enough for that software to remain relevant. These conditions require creativity and adaptability, which relies on teams that deeply understand Agile principles and organizational goals. To thrive in these imperfect settings, project managers must equip themselves with deep knowledge to implement practical, responsive strategies. Agile is spreading beyond software projects into all domains of project management. This is not all good. Not all types of projects, not even a majority of types of projects, are improved by Agile project management. Misapplied, Agile can be perceived as a bothersome management fad, and it can make it more difficult to use Agile where it is useful and appropriate. The best embodiments of Agile are undogmatic, practical, and thoughtful. It takes critical thinking to apply Agile successfully. Carefully consider the appropriateness of Agile and understand the context of projects in the enterprise. Making an entire enterprise look like an Agile software development team before everyone involved has taken on board an understanding of why Agile project management works better for software development projects amounts to pushing Agile as a fad. This is the worst formulated of all the Agile principles. Business people and developers must work together daily throughout the project. The term business people is a caricature of a software developer's idea of his colleagues. Everyone in an enterprise is a business person and has to internalize the core elements of an enterprise's business. Agile project managers and project participants have to go above and beyond this Agile principle to succeed. But the business people didn't tell me is no excuse. Taken literally, the principle that seems to say that the business tribe and the coder tribe need daily face-to-face meetings will not scale to an enterprise running several software development projects simultaneously. You can't have the senior management of an enterprise paying attention to multiple software development projects on an ad hoc basis. The people who created the Manifesto for Agile Software Development and the principles of Agile did not emphasize how Agile projects interact with the outside world, which is fair. It's difficult enough just getting software to happen. That leaves it up to the practitioners of Agile project management and their team to understand and communicate the need for agility, and to do it in context, in a way that is thoughtful and knowledgeable about enterprise-wide practices and goals. The software development team is just one part of a larger organism that has developed ways of working that, for the most part, do not need to be changed for the sake of making software. Making everything agile is unnecessary and counterproductive. The challenge is this: software development is different. It needs different project management, but it also needs to mesh with management decisions about project goals and resources. These decisions are influenced by the differences in software development projects compared with most other undertakings in an enterprise. This boundary, this interface, is where mutual understanding becomes crucial. Communicate in a way that can be clearly understood. Remember, working software is the primary measure of progress. If the project manager doesn't know how to create and use communications channels with key interested parties, especially those making decisions about project resources, that's a big decrement in the odds of success for these projects. Agile is fundamentally better in ways that pre-Agile approaches to project management cannot accommodate. That is, there's no way to fix previous project management approaches to be as good as Agile for most software development projects. Should organizations and their management therefore just go along with Agile? Or are they looking at the difficulty of finding that perfect team of quality, craft-minded, yet business-savvy software developers who will internalize their organization's strategic goals? And are they despairing? While Agile is better suited than any other way we currently do project management and software development, There are many cases where Agile, especially if it is treated as a standalone entity, goes wrong every bit as badly as traditional project management. Among them, Agile looks easy. Agile goes without complexity in project management tools in favor of simple tracking of what is being worked on and what is complete. This is a great virtue of Agile, but the surface simplicity of Agile invites people to practice it without being ready or able to take on the complexity and risk in developing software systems. Nothing about software itself gets simpler with Agile. Agile doesn't handle mismatched resources and projects. The right team for one project isn't the right team for other kinds of projects. A team that is more than adequate for a simple project can be over their heads in complex, high-risk projects. Agile project management favors a fast start to projects, but without much predictive power about the total requirements for a project. Inclusiveness and feature creep. The inclusiveness of design input from all team members is meant to enable problem solving and to find good ideas among the kinds of people who are likely to have good ideas. But this inclusiveness can lead to feature creep and ego-driven elaboration of an implementation. Feature creep can lead to delays and budget stress, especially later in the project. And it causes loss of focus and relevance. Agile projects need strong product management over the entire course of projects. Stories are not useful task descriptions. In some forms of Agile, task descriptions are called stories, which debases the importance of clarity in writing task descriptions. It is okay to defer having a complete task description, but it needs to be sufficient before implementing. Agile enables ignoring architecture. The superficial nature of stories, which are sometimes illustrated by drawings of the desired user interface, or UI, make Agile approachable to non-technical stakeholders at a potentially high cost. Agile enables a project to proceed without an architecture. On top of that, it disincentivizes project participants who know how to value architecture to spend time on architecture, because architecture does too little to bring story-driven Agile projects to completion. Agile project management can give the illusion of progress, learning, and improvement while masking problems that grow in size and complexity. If a project encounters problems, and if those problems cannot be solved by grinding them down in the iterative Agile model, Agile leads to project failure in deceptively hopeful incremental steps. If a project is on the road to ruin, Agile won't map an alternate route. When a project diverges from plan, Agile iterations only provide a keyhole to look through. Agile won't reveal the scope of the problem. Agile gurus might exhort practitioners to fail fast, but this leaves them short of a means of knowing if, in fact, they have failed. It is difficult to make even highly competent outsourced resources behave as if their goals are completely aligned with their clients' goals. Outsourced implementation requires in-house discipline. Contract resources are the least likely to rein in any propensity to add features to a project, and yet many projects are impractical without outside help. Software metrics in Agile are as bad as software metrics ever were. Velocity is no more rigorous a measure than the obviously meaningless K-lock, or 1,000 lines of code, from the 1970s. Some ways of practicing Agile are hostile to thoughtful task estimates. Where traditional project management methods rely too heavily on early-stage task estimates, Agile, especially the Scrum variant, encourages off-the-cuff estimates in imprecise, unitless numbers. Agile metrics, which introduce more problems, then use those estimates and those unitless numbers to evaluate individual contributors' performance. Working software is all that matters. There are many proposed ways of improving estimates in various Agile variants. Some, like a game called Planning Poker, which will get you a C- in both statistics and psychology, seem like a useful process, but are deeply flawed. It is possible that the best way is to make no estimates at all. Ask yourself, where in the manifesto or the principles are estimates mentioned? Incremental testing isn't sufficient. Agile claims to deliver potentially shippable products early and often, but that ignores the insufficiency of incremental testing compared with a full test plan that includes probing edge cases, capacity testing, etc. Making incremental testing work is difficult. Automating incremental testing requires a potentially large commitment of resources. Agile projects can turn into a death march. When management becomes too engaged in daily measures of progress, Agile enables managers who often lack domain knowledge to continually harangue developers about task completion. If a project is late, a stand-up or scrum meeting can devolve into an uninformed flogging session. These are not the only blind spots Agile teams and project managers may have in the larger context of an enterprise. There are many attempts to extend Agile or to build frameworks around specific Agile practices so as to put guardrails around Agile. Often these attempts only add to the trove of jargon Agile has already accumulated. These attempts contravene the people over process spirit of Agile. Pathologies typical of Agile projects may reflect problems in the organization using Agile rather than Agile itself, but that is hardly an excuse, any more than the naive misapplication of traditional project management is an excuse for its unsuitability to software projects. The way to avoid these and other potential problems with using Agile is to understand Agile and understand the context in which it is used. Know why Agile is the way it is. Know where the weak points and blind spots are. Know why software is different. Know how to communicate with your colleagues outside of Agile projects. Have the critical thinking skills to discover and solve the problems that cannot be contained in training courses or books. Feature creep deserves particular attention because it highlights the tensions in the Agile principles. Feature creep is the tendency of projects and products to accumulate features because project participants find it feels safer to have too many features than to risk missing a decisive feature. On the one hand, the Agile principles appear to open the door to feature creep that might have been contained by carefully crafted specifications in the waterfall approach to project planning. Welcome changing requirements, even late in development. Agile processes harness change for the customer's competitive advantage. On the other hand, the principles also say, simplicity, the art of maximizing the amount of work not done, is essential. To sum it up, be open to changes even late in the project, but retain simplicity, and by the way, do not overstress the people on the project team because Agile processes promote sustainable development. The sponsors, developers, and users should be able to maintain a constant pace indefinitely. Simple, right? This illustrates one of the ways the Agile principles are an inconsistent and conflicting bag of recommendations, not a prescription or a recipe book. It gets worse. All of the attempts to turn the practice of Agile into a reliably repeatable recipe have just weighed Agile down with superfluous rules and jargon. This also, once again, illustrates why product management that is engaged with team priorities and tuned into making Agile practice work in the context of specific projects is essential. The product manager is best placed to resolve these conflicting principles, and a team that knows this fact and holds the product manager accountable for resolving potential feature creep is well prepared. Feature creep and the difficulty of containing it is one reason why the role of product management is central to success with the Agile approach to software development. Even if an organization does not make software products for use by external customers, almost all the functions performed by product managers, no matter how you refer to this role, are still crucial to success. In the Scrum variant of Agile, implementation iterations are called sprints. Sprints are planned for a fixed short interval, often 2 weeks. Daily meetings called scrums or stand-ups are held each day and are limited or time-boxed to a short time, often 15 minutes, during which impediments to completing tasks scheduled for a sprint are presented in a format where each participant recites what they completed the previous day, what they plan to complete this day, and what impediments they've encountered or believe they will encounter. This format is one example of why meetings in Scrum are sometimes referred to as ceremonies, since they rely on ritual rather than a prepared agenda. The Scrum Master runs these meetings. Tasks and other elements of the project plan are called artifacts. Scrum is by far the most common form of Agile project teams practice, or attempt to practice. For that reason, and because of the gratuitous jargon, Scrum comes in for the most criticism. There are no cookbook approaches that raise the likelihood of project management success. Every organization's project management approach should evolve to fit their specific needs. Going on a journey to become a better, smarter, more well-equipped manager of Agile projects as a member of a largely self-organizing team within an enterprise that is supportive of agility in software development is the best way to make it more likely that an organization will experience the benefits of agility. This is what Ron Jeffries, one of the authors of the Manifesto for Agile Software Development, had to say about the state of Agile. Over a period of years, I've heard from many developers who say that Agile sucks. Usually, they say that Scrum sucks because most people in organizations trying to do Agile are in organizations trying to do Scrum. I've tried to help these people understand that their organization is doing Agile wrong. They're not doing what the Manifesto authors recommended, what Scrum recommends, and what the many Agile software development experts recommend. My hope was that these people within the sound of my voice would help themselves and their organizations move closer to the real ideas behind Manifesto Agile and away from the many forms of faux Agile or dark Agile that we see all around us. To move closer to the real ideas is not just an ideal, it is the most practical way to improve the chances of good outcomes. Focusing on fundamentals, applying critical thinking, and knowing where Agile works and why, and where and how it doesn't, is what the people in enterprises that create software need to keep in mind to reach that goal.